quickly. A particle of mass 4m rests on the rough horizontal table. The coefficient of friction between the particle and the table is half. The particle is connected by means of a high index inelastic string passing over a smooth like pulley at the second smooth pulley of mass 3m hanging freely. The second string passes over pulley B connecting particles C and D of mass m and 2m respectively. Find the common acceleration of A and B. Also find the common acceleration of C and D relative to B. What is the actual acceleration of B? Okay, so try to imagine yourself on a pulley. This pulley is not moving, so you're like abseiling. You're abseiling down at 2 meters per second. That's an acceleration of 2 meters per second per squared on your way downwards. Now that's when the pulley's fixed and not moving. However, if the pulley is moving downwards as well, an acceleration of 3 meters per second squared, you then have a combined acceleration to an impartial error of 5 meters per second squared. Nextly, if we think of it in another way, where you're going upwards instead of downwards, in this case you have an acceleration of 2 meters per second squared upwards. However, if the pulley itself is moving downwards at an acceleration of 3 meters per second squared, overall you will have a downwards acceleration of 1 meter per second squared. Once again, if this was A and B, you would say simply it's A minus B. What we're going to do next is we're going to look up at this diagram. Particle A is getting pulled by tension S across to the right. Particle B is getting pulled by tension S upwards. Particle C is getting pulled by tension T upwards. And particle D is also getting pulled by tension T upwards. Particle C is mass M, particle D is mass 2m. This results in a weight of mg, for C and a weight of 2mg for D. Nextly, we're writing down 4m is the weight of particle A, and 3m is the mass of particle B. Now, common acceleration between particle A and B, because they're linked together, as shown by the yellow line, is acceleration A. Nextly, common acceleration B relative to the pulley of particles C and D. B goes upwards because m is lighter than 2m, so that means C goes upwards and D goes downwards relative to B. Nextly, this means that particle D has acceleration A downwards and acceleration B downwards, which means it has acceleration A plus B downwards in total. Okay. And this one here, particle C, which is going downwards at A and upwards at B, you can present it two ways. You can present it as A minus B or B minus A. A minus B, you think it's going up downwards because A would be bigger than B, and if it's B minus A, you think it'd be going upwards. Okay. Now, next we have the weight of the particle. The weight of particle A, which is 4m, so that makes it 4mg. The R value will also be 4mg. Mu R would be a half of 4mg, which is 2mg. If you reread the question, find the common acceleration A of A and B. So common acceleration is A. The common acceleration of C and D relative to B is acceleration B. And the actual acceleration of D is A plus B. We're next going to take the particle going to the right. We're going to take particle A. Its force is going to the right because it's driven by tension S, take away 2mg. Okay, and then what we have here is 4ma because it's mass times acceleration, which is 4m times A, which is S minus 2mg. Now, if we take this particle in isolation, please remember there's actually 3mg in there. I'm going to fix that later, so don't you worry. It's going downwards with acceleration A. So this 3m particle is going downwards with acceleration A. So it's going to be, and remember, tension is actually dragging it downwards from its perspective. Okay? Imagine the case where you're pulling up a friend. His perspective, the tension's pulling you up, but from your perspective, the tension's pulling you down. So in this case, the 3m is getting pulled down by the t values. Okay, it's getting pulled up by the s and down by the t. So Force going downwards is 2t minus s, but remember to add in the 3mg weight going downwards as well. I'm going to do that at the end. So 3ma equals 2s, 2t minus s, but there's also a plus 3mg because the 3mg is also downwards. I'll do that in a second. Now, in particle C, what we have is we have t going upwards and mg going downwards. We're using a minus b. If we use a minus b, so force equals ma, and a minus b is going downwards, what we can say here is that F equals weight going downwards minus tension going upwards. So weight is mg minus t. Now, if we argued that instead of going downwards, it was actually going upwards, we can change around it, and we can say that we could have said that m equals b minus a, and then it would have been t minus mg. So it would have been just the opposite way around. It would have been the minus 1 version of that. I'll do that in a second as well. And finally, see t here? We have t going, we have particle d is going downwards with a minus a plus b. So its weight is beating tension. So it's going to be 2m times a plus b, which is going downwards, equals weight, which is 2mg minus t going upwards. Multiply that out, we get 2ma plus 2mb equals mg minus t. So we have this equation here. Now, please have to modify this one. Remember what I said earlier is that it actually has a 3mg in there as well. You can't neglect the weight of the particle, so that's 3mg going downwards, so it's a plus value. And then finally, I'm just going to show you this is the fourth equation, but I can show you that the minus version, the b minus a version is the same. If I said b minus a, it'd be m times b minus a, and b minus a would be implying that b is bigger than a, so it's going upwards. In this case, tension would be the bigger number, causing it to go upwards, minus mg going downwards. It's simply the minus 1 version of the other equation, so it doesn't matter. So, when you're all said and done, you should end up with 4 equations, and part 2 of this video will be done for you in a minute. So here are your 4 equations, and your job is to find out what here's your 4 equations. You have to find out what A is, B is, and then A plus D. And that will be done. Okay, let's look at that.